This is the Amp Hour Podcast, recorded November 25th, 2013. Episode 173, with guest Jerry Ellsworth. Intense Illusion Introduction.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm Jerry Ellsworth of Technical Illusions.
Thank you very much for joining us again, Jerry.
Jerry, I don't know if you saw this, but at the back of the coupon book, now that you're out of coupons for being on the Amp Hour, you actually get a free ice cream cone as well as 4 appearances on the Amp Hour.
All right. and now, do I get to exceed the 3-hour maximum of...
Vincent.
Vincent Himvey, right.
Well, you could have taken it as a lump sum payment up front. That was the 3-hour show, or you can get 4 1-hour shows. So, unfortunately, we have to limit you. You can do whatever you want. We'll talk as long as we can.
All right, maybe we'll keep it shorter this time.
Yeah.
Hey, Chris, she's really cashed up now. We should have
ask
upped
for
our
some
price.
money, huh? Yeah.
We
this
should
show
have
brought to you
really
by the Cast AR.
Technical Illusions.
Jerry, we'll talk after the show about how much that just cost you.
Gulp.
Well, congratulations. That is so awesome. So people don't know, Jerry and the Technical Illusions team and the Cast AR got funded for over $1 million, which is woohoo. Yeah,
Woohoo.
Awesome. That's a lot of zeros.
Come on, Jerry, admit it. That's the magic figure you were looking for, right? You wanted the 7 figures.
We did.
Everyone wanted it.
Who doesn't?
I know.
I'd be happy with 20 grand, Dave. You know what?
Right,
I'm just going to do this on a shoestring. Who cares?
So there's these analytical tools that kind of track your Kickstarter and tell you what you're trending for. So day one, when everything was going really well, it was something like $10 million or something ridiculous.
Yeah.
And we're like,
No.
oh my gosh, will this keep going? Of course it doesn't. It gets extremely depressing in the middle. And then it was trending towards something like, 900,000, 80K.
Yeah.
And we're like, no.
So close.
I saw that graph. It's actually an exponential decay graph. Except you had a little tail up at the end, I think, because of, last minute flurry of people go, oh, no, I'm going to miss out.
Yeah.
But, it's
strange psychology in Kickstarter. Folks, there's a lot of early adopters that get on, immediately, and then everyone warned us ahead of time that it's going to be depressingly slow in the middle, and it is depressing because you see, hundreds of thousands of dollars come in the first couple of days, and you're like $10 days all through the middle. And we were hitting lots and lots of press, really big press sites were picking us up, and newspapers and TV stations and stuff. And each one of those was just this little tiny blip right through the middle. Nothing we could do would, bring it off that flat. We're trying to adjust our story and try to fix all the missteps that we had earlier, and it's just once the people pile through the first couple days, they never come back.
I guess you just have to have low expectations from the beginning, huh? You just can't. You got to kind of just run with it and try and promote as much as you can, and then see what happens. And of course, get Chris Gamble to be on the last 10 minutes of your campaign by accident on Skype.
That's what got him over the $1 million.
Yeah, that's what it was.
That was, Chris showed up and boom, right over $1 million. Fun having you on right up to the, last couple seconds. We actually counted down, all of us.
Yeah, it was. That was a good time. I feel bad for making fun of Rick's couch so often.
I was telling Dave. Sorry, I forgot your name there for a second. Before we got going, that the only thing that would bring us off the flat line in the middle was we were starting to go show bigger companies. So there were some big companies wanted us to come in and do demos. And those were more valuable than press because we actually got in and showed, 50 to 100 people one-on-one the unit.
Yeah,
and
that's great
they'd all
feedback.
race home and race back to their workstations and buy it.
Yeah.
Cool. That's really surprising that, with hindsight, it's not, because you've got that factor of, that hands-on, people can scratch and sniff, and actually that wow factor, oh, wow, this does actually work, and this is really cool. And, they race back to their cubicles and punch in their credit card number into Kickstarter.
Seems to me that Kickstarter is kind of going through a transition right now. It doesn't seem to be quite as... A few years ago, you could throw a brick up there and sell a couple $1 million of them.
Yep.
Now it's people are a little wiser.
Yeah, there's books about how to do campaigns. There's all this, I wouldn't say mythology, but there's a strategy around it now too. I mean, I remember even you were talking about the making of the video, and you knew it had to have certain elements, and you've seen what works, what doesn't. So there's a science almost to it, but at the same time, it's you still need to have a good product, like you guys did, in order to get to certain goals. So
you actually have to deliver this time. It's
no,
really?
And you foolishly, Jerry, put a realistic time frame on your delivery. You fool.
Yeah, we got a little. I mean, that's an aggressive time schedule too. But people are like, a year? Really? I have to wait.
That's
a year?
how long it takes. Exactly.
Wait, what did people expect?
Yeah.
I don't understand it.
Yeah.
Wait, did people expect 6 months or something? I'd seen that people were saying that this was an aggressive or a realistic timeline versus a super aggressive one, but a year? That's it?
Oh, I'd say it's aggressive. That's pretty aggressive, actually.
Yep.
Yeah, I would agree. You're making friggin' chips.
Folks just don't know. Folks don't know. So that's the thing. I had some people posting comments, I was mentioning oh, it's great, we're over whatever, $500,000. It's getting into the realm where I can hire a few more mechanical engineers to get us through all this. And they're like, someone posted a good mechanical engineer could crank this out in a month. I'm like,
right.
Yeah.
So sorry, you don't understand realities of manufacturing.
Yeah. Well, maybe a prototype, 3D printed, prototype, maybe. not a mold design.
And spins on top of that.
Yeah, right.
See, that's the thing, because you're actually manufacturing a real mechanical sort of consumery type product. You're not just making an Arduino, blank board. Or, just an assembled PCB. This is a serious product.
Yeah, we have to go through. I see our biggest challenge in the next year is the mechanical. We have the glasses, and the glasses have an optical component to them. So there's the optics engine that has special materials in it, like liquid crystal polymers for the plastics, and then the actual frames themselves, which have to be of a certain type of plastic. And then you have hinge, the arms on them hinge, and we'll have to have some work done around the electromechanicals of how do you get the wires through the hinge. So there's effort there.
There's a couple of design spins right there.
All the wires?
Well, yeah.
Yeah.
I mean,
absolutely.
you're not going to get that first spin. I mean, if you do, you're incredibly lucky.
Yeah, you're going to be incredibly lucky if your part ejects the first time out of the tool. So,
right.
I've worked on designs where, the first time we squirted plastic into the mold, we broke the injection pins or the eject pins off because it jammed up so hard.
It just stayed in there, and then the pins gave first, huh?
Yeah, they bent.
That's some darn strong plastic.
So, do you think that with
the tool gets hot?
Yeah.
Well, yeah.
The tool gets hot, and your tolerances aren't quite right on the pins, and then the pins stick, and you have this press that's pressing at many tons.
Right.
Pow.
More like ping.
And ping.
Yeah.
So, did you think that because you're experienced in bringing these consumer type things to market, and you know what the realistic timeframes are, and you were honest about it, did that potentially limit your funding, perhaps? Although it's hard to tell without...
Yeah, a control group.
Yeah, experiment. Yeah, exactly.
Well, just the way people were complaining about certain things, being very honest about timelines hurt us. Just people well, I don't want to wait a year. That was some of the things that we heard quite a bit. Mm-hmm. And then I guess if we would have lied and said 6 months and then just delayed, whatever, we could have got a lot more. And then a misstep on our part was not subsidizing shipping to Europe. So we tried to extrapolate out what it would cost to ship all these units from various logistics centers out to different places in, like, Europe was particularly expensive because we have this surface that's a meter long. It's like it's rolled up in a tube, and then you have a box that has the glasses and the other peripherals in it. So it's 2 packages, and it's oversized, and
right. It's got electronics for like customs and everything else. I'm sure that's kind of a hassle too, right?
Oh, we didn't understand that the psychological aspect of shipping being a huge percentage of the total cost. So the units were $189 and shipping was anywhere from $60 to $80. Even though they're completely decoupled from each other, people are like, this is crap that you're charging me $70 for shipping on something that only costs $189.
Yeah. You should have told them that they could get like a plane ticket and come see you and pick it up themselves.
Right.
Exactly.
Speaking of which, who are the 2 people who bought the $10,000 hand-built prototype?
She can't tell you that, Dave.
Oh, well, one of them's public. So it was Palmer from Oculus, which is a kind of competing product.
Oh,
which is pretty cool.
So it's like him stealing like the Iron Man Mark I suit almost.
Right. So do you have to now busily head down, bum up, and build 2 full prototype units?
Yeah. Luckily, it's not too far off from what we have. We didn't make big claims about it being production ready kind of prototypes, so there'll probably be a glob of hot glue in there somewhere.
Awesome.
Oh, yeah.
For your $10,000. Here you go.
I'll use
it'll be the nice hot glue.
Yeah, it'll be special. Maybe I'll paint it gold or something.
Yeah. Put glitter on there. People like glitter.
Glitter. I like that.
And 5 people paid $3,500 to come and have tea with you and visit and tour the facility. Wow, people are really don't mind spending money, do they?
Well, we did a lot of talking with a PR person before we did this, and they filled us in on kind of the psychology of there's certain folks that have a lot of money and they have everything physical that they want, and they're out looking for the experience, and that's very important to them.
Right.
So we chose to put a very expensive, here's an experience type thing, and they sold out.
Yeah.
I didn't come up with a name, though. That was Rick and Josie were like, tea with Jerry.
Yeah, it doesn't exactly.
I think someone's coming from Europe. So we've been in discussions of like what time would be good for folks to come out, and they're going to have to make very special plans to fly out.
Well, let's dig into some of the you mentioned the mechanical side of things, but what about, as we're moving, so you've got this big hunk of cash that shows up in your bank account. Kind of walk us through.
But does it? Does the money instantly show up in your bank account?
There's some cool down period through Amazon. So Kickstarter takes a chunk of it for their percentage, which I think is 5%, and then Amazon takes 3% ish, something like that. So a big chunk gets lopped off the top, and then there's a certain amount of people's, like, their credit cards were maxed, or their credit card got stolen during the month, or something goes wrong with the transaction, and it doesn't go through. So there's a certain percentage of the money never shows up that way, and then there's a certain amount of money you need to leave, like in Amazon, just in case there's chargebacks or some credit card were stolen or there's some scam. But yeah, pretty much a big chunk of money you can just transfer right into your bank account after a certain amount of time.
So then what? So then buying spree for soldering irons and
people. I think
FPGAs.
People are in
That's actually
people. Yeah. How do you buy? Where do you buy people? Because I heard that was illegal.
People.
We are human. We are human.
We've. Before even Kickstarter ended, we were already trying to recruit folks. So we've been talking to a lot of folks trying to get a lot of contractors up front because it's going to be difficult to get quality full-time employees in a very short amount of time. Mm-hmm. And so we're trying to get the mechanicals underway immediately because that's our longest pole in the tent is from the way we see it. And so that's been a lot of our effort. It's just trying to find some quality people. I am looking for a new oscilloscope. I'm working with sticks and stones right now. I have this old 100 megahertz scope on my bench, and everything that I'm doing is gigahertz range. So it's like everything looks like DC to my crappy old oscilloscope.
You gotta fake it out. Do some shifting, frequency shifting or something.
Down converted or something.
Yeah, exactly. Yep. So we probably should ask: Are you like? Do you want people to email you if they're like, "Oh, I definitely want to work for you"? Or is
absolutely,
yeah.
We need more EEs. We need more mechanical engineers, and maybe even, I hate to say it, industrial designer.
Oh no! Ooh, artsy fartsy types.
Artsy fartsy, make it look fancy pantsy.
Yep.
Exactly. Although
how do you hire people like that? Because you don't. How much experience have you got in that area, like hiring a good mechanical person? How do you know they're good? Do they bring their stuff in and, hey, look what I designed? But it took me a year and you need someone to do it in a month.
Yeah, exactly. Look at their portfolio of stuff. I've assembled teams before on both mechanical and electrical, but it's difficult. Hiring is always the biggest challenge in any company. So... and that's why we're looking for some hired guns to get us going immediately while we look for the rainbow unicorn that can do everything.
Rainbow unicorn with a soldering iron for the horn.
Exactly.
They crap out injection molded parts. And rainbows.
It's this whole design cycle is going to be kind of fun and exciting because there's so many disciplines in it. So in the early stages, we can have someone that's maybe a bit more junior. The designs don't have to be manufacturable for the first. We have some early units that we're going to ship, which are going to be. I think we have 70 or 80 of those committed.
Oh, right.
Those could be machined out of a solid block of aluminum, and it doesn't matter the cost of those. But you really have to find that unicorn, the person that knows how to make the tools.
Yep.
And someone that's very senior at doing that, or you're going to have like these issues I talked about before where injection pins, seize up.
Yep.
Or
I've been amazed. So I've been working with someone who's like a mold designer and stuff like that, and I just... I thought, I've seen a 3D printer before. How hard could it be? But it's like, injection molds, like the molds themselves are just like works of art. They're cut out of like these huge blocks of steel. And I'm sure you've done all that stuff before too, right? We've worked with like that kind of mechanical stuff.
Yeah, I've worked closely with folks like that. I've never actually cut a tool myself, but...
Oh, no, me neither.
But fortunately, our volumes that we're working in right now are fairly low volumes, so we can cut aluminum tools, so soft tools.
Oh, soft tools, okay.
Yeah, so they're a little bit more forgiving,
right.
And you can cut them much faster.
How many shots do you get out of an aluminum tool, usually?
It depends on how much you care about surface finish, because each time you shoot a charge of plastic into it, it slowly erodes the tool, and you get checking on the tool. And like if you look at a really cheap like import toy or something like that, and you kind of look at it and you see like kind of looks like spider webs in the plastic or a lot of shrinking and stuff in an area, you can usually track that back to like checking and erosion in the tool or poor tool design if it's shrinking in it. But
Huh.
It's
I
a whole
forgot
art.
about the toy stuff though. I'm sure you have a wealth of people that you know in the toy industry, right?
Yeah, I've been reaching out to a lot of the contract manufacturers that I worked with before, and various folks trying to get them on board. A lot of them are already doing something. So I tried to give some of these folks heads up that this was going to happen, but until you actually do the campaign and it's successful, it's hard to like lock anyone in.
Right, exactly. allow me to jeopardize my future by not going and looking for new work, just so wait around in case you do get $1 million.
Well, that's the thing. A lot of your reputation may ride on the ability of a contract manufacturer to do what they say they can. And if they leave you in the lurch, well,
I'm
it can all...
absolutely terrified that something's going to go wrong this year, like some disaster, like our boat sinks. It has our entire load of cast ARs on it. That's all.
Yeah, everyone's going to believe that, aren't they?
Air freight, Jerry. Air freight.
Or the 747 goes down into the ocean.
Submarine, Jerry. Submarine. Carrier pigeon. So I guess my question about with the mechanical stuff and even hired guns, I mean, from estimates I've seen before, it doesn't seem like $1 million would get you. I mean, like, it'll get you a lot, but it won't necessarily get you like a ton of people time, right? I mean, like, how long do you think that'll take you?
Well, that's why we're working on secondary funding with VCs. So that was actually part of our plan from day one, a strong showing on Kickstarter. And before Kickstarter, we went to a bunch of venture capitalists and showed them the product. And of course, they came back like, yeah, we'll give you some money, but we want a big chunkier company. And so now we've gone out and we've shown it.
It's all right, I guess.
Yeah. Usually that's their attitude. A lot of times, like, yeah, it's pretty cool.
Yeah, they're like the high school cool guys, right? And they're like, oh yeah, well, I don't need you, you need me.
Exactly. And then as soon as our Kickstarter, like even halfway through the Kickstarter campaign, we started getting phone calls and emails from these folks like, all right, let's close this deal. Let's close it. And now we're pushing back a little bit more now.
Yeah, but, man, that's a mess. But I guess, I mean, that's the thing. Like, so I always wondered about like VC stuff, and I was like, oh, I would never want to, take money from that kind of thing. But money just transforms into like, something you have into a way that you grow faster, right? It's like a way that you can hire more people so you can do more awesome stuff and get it out the door. And it's just
with
a sacrifice
less
you
risk,
can make.
Really, of it all falling apart at the 11th hour.
Yeah, like if you look at
because all your money runs out.
You look at our Kickstarter, we have $1 million. We have a fixed cost of $300 to $400K sitting there. So, that's not going to buy a lot of full-time employees. But if we could go raise a chunk of money from VCs, then we can staff up and look at what's going to happen after 2014 delivery of the Kickstarter units. We start planning for 2015 for a more mainstream launch of the device.
Holy crap, is it 2015 already? Well, coming up. That just blows my mind. I'm sorry, my life is flashing before my eyes.
You're 2 months away, right?
No way we can do a mainstream launch in 2014. That's very, very unlikely. Just because the product isn't polished enough. But if we could get a team of enough people working, especially on the software side, and we learn a lot from the Kickstarter units that we build, then we'd be positioned very well for 2015.
Right. So what a lot of people probably don't understand, they think, oh, you got $1 million, but if you don't get VC funding out of this, you're probably not going to make a profit on this thing. I can't, with hiring all the people and all your fixed costs and prototype costs, there's just no money in it.
Yeah, we never planned a profit at all. We, we discussed a lot, like, well, what margins should we set the units at? And we decided to go with regular retail margins like you would get out of a normal consumer device so that we could present it to the market in about the same form that it would show up in 2015. Right. So that we could show the viability of it. If we came out with like a $900 unit, we probably could have sold, hundreds of them, had hundreds of thousands of dollars to work with, and it would have maybe been easier, but it wouldn't have set us up for in a good position for later.
That's a whole strategic, long-term thinking plan, isn't it? I mean, there's a lot of thought really has to go into that. Yeah, I know.
That's what I keep thinking is like, this is like really, it really sounds grown up,
Yeah,
like,
I know.
Like you're making video. Like I was thinking,
it's like, be a hacker, Jerry.
This is for video games. Like I mean, this is so much. There's such business behind it. It's like, oh my god, and technology behind it. It's like good gravy.
Hiring people?
Yeah.
What?
Well, our whole summer has been like trying to figure out which way to go with this. So we didn't want to be some niche-y thing and just make a few $100,000 each and be done with it. So, it wouldn't be worth all the effort that we put into it. So, our bigger plan is, go for the gold and see if we can turn it into something bigger. And, if we appeal to the video game folks, because it's a huge market and they're usually the early adopters, but there's actually, personally for me, there's so much more exciting stuff you can do with augmented reality glasses and our input devices. And so we did the Kickstarter, and all these companies came out of the woodworks, like big companies, like, hey, you guys have finally developed what we're looking for. And so that's also part of our 2015 strategy, is like, there's going to be mainstream consumer product, and then there's potential for these really big high-end things.
All right. So could you go over some of not the actual companies that you talked to, but like the some of those applications you had in mind? Because I really like the suggestion you guys had about like CAD and doing like 3D CAD type stuff.
Yeah.
But did you have other big ones?
So there's ones in the entertainment field where location-based entertainment. So maybe super high-res versions of the glasses, and you give them to people and they wander through an environment and they have some kind of multimedia interactive amusement park type thing. There's the CAD stuff that you're talking about. Architectural companies are very interested in this, and even kind of geological survey companies are interested. So, currently, like, people that go look for oil deposits or coal deposits or natural gas or whatever, they do all the surveying and they try to present the data to their clients, and it's just a piece of paper with a bunch of squiggly lines all over it.
That's the industry I come from. Yeah, I can tell you, it's a big deal. Being able to visualize the deposits and stuff like that is a huge deal, and to do it in real time as well.
Yeah, with our tech, you just put the glasses on your clients and tell them why their land is worth so much money, because they could walk around the table and look at this topology of the land, and they can see potentially where the oil deposits are. And so, yeah, that's just some of the applications that are non-gaming, which are going to be pretty interesting.
By the way, Jerry, just to clue you in, these companies have billions of dollars. Okay, they have no problem signing $1 million check for just some little widget. Okay, so
well, guys, video games are out and
charge
oil's
like a
in.
wounded bull. You can make a $100 million business selling 100 units.
Yeah,
I'm not kidding.
No, yeah. I believe so. What would? I guess the video games kind of drove the whole thing in the first place, right? Because I'm always confused about that. I've never been in the consumer space, but that seems like a really shitty space to be in, if you excuse my French. I mean, like, margins are low and the demands are really high, and you don't necessarily... I mean, like, in your case, you're doing really cool technology, but, like, in a lot of the business-to-business type stuff, you get to work on really specified things and like, high-end, high-margin technology. I don't know. It just seems like...
Yeah. So the Kickstarter for us... we really wanted to kickstart some hardware and get it out there and get it to developers. So that was one aspect of it, is just to get a lot of these units in folks' hands. But we also looked at it as a huge PR thing for us. So if we never make a penny on the Kickstarter, the PR that came out of it is, you cannot buy that. You couldn't buy it with the amount of money that was in our bank account, at least.
Right.
So...
yeah, that's a really good point. It's like, again, all the grown-up stuff that you don't want to think about, but at the same time, yeah. I mean, like, it's like YouTube won't do it all, right? I mean, like, you have this huge following on YouTube, just like Dave does, and it's like, even with that, you're not going to reach a lot of the people. You still have to go through these traditional media outlets, which is, for better or worse.
Yeah. It's surprising where, like, some of these larger companies heard about us, and it wasn't through like gaming media or through my YouTube channel or anything like that. It was like they were reading New York Times and there was some little blurb about it, and mainstream media, because we got onto some of that stuff.
That's really cool.
Ride that dinosaur.
It's weird. It's weird.
Exactly.
And it's no, it doesn't matter how much you try to predict this stuff; it just never turns out as you expect.
Yeah.
Like, we expected some of this stuff, but the things we expected didn't happen, and lots of other things
Do you have any demographics of the people that are back in at all? Like, I expected like 1,000 just off the bat of, fans of your work, people who've been following you forever, just buying in because it's something you worked on. Or are they all gamers, or any data on that?
I kind of peeked at some of that stuff. I haven't analyzed it very close, but there was, I put a YouTube video up, and that was directly from that YouTube video was a huge percentage on the first day.
Right.
So yeah, that's
what I'd expect. Yeah. Your existing audience.
And so there was all these theories about how to do a successful Kickstarter, and we were told things like you need to get 20% the first day, and if you get 20%, then you're likely to reach your funding goal, and right. We blew right through that in the first 53 hours. We blew past that, but it's definitely you have to have that excitement there the first few hours, because when these tons of people will pile through, and if the excitement's there, they'll join in.
How did you set the $400,000 target? What was the how did you come to that number? Did you extrapolate X number of units to make it viable, and that's just the figure that popped out, or?
So there's a psychology around Kickstarter, at least this is the conventional thinking, is that if you set your goal really high, like if we would have set it to $1 million, we probably wouldn't have made it, because people would have looked at that and said oh, they'll never make it to $1 million. And if you set it to 100,000, us folks in the industry that are savvy about manufacturing will be like, oh, that's bullshit. They could never make all the tools. And so what we did is we spent all summer beating up on the bill of materials. We reached out to a bunch of contract manufacturers. These are the parts we want. And we worked on the bill of materials continually. And so that's how we set the price. And then we extrapolated out off of our units that we needed to sell, and that's how we came up with our total unit price. And 400K was what Rick and I, we sat down, we're like, okay, if we only get 400K, can we do it if we threw our own money in there just in case something horrible went wrong?
Yep.
And that's what we did. It's 400K, maybe we'd have to chip in another 100K if something bad went wrong. And that's how we came up with the number. And I'm not sure if it hurt us or not, because as soon as we hit 400K, our pledges went way down. So
well, that's another part of the psychology. A lot of Kickstarter projects only make just a little bit above their target if they make it.
Yeah, so I wonder if we should have set it to 500K, where we would have had a little bit more buffer, and I don't know what would have happened. It might have extended our growth spurt there for a little bit longer. But what's interesting is, as we started talking to folks about how to do this Kickstarter, people came out of the woodworks everywhere that were experts in Kickstarter, and for only 2% of our our Kickstarter funds, they would give us the magic sauce to make it happen.
Oh, really?
It's go blow
Snake
yourselves,
oil at every
guys.
turn. Yeah.
There's a whole
but there's people leeching. There's a whole market out there leeching off that, is there?
Oh yeah, and even after Kickstarter, there's people contacting us "Ooh, congratulations on your super successful Kickstarter. Now, let us take care of your clients, and we'll keep them happy."
Logistics.
We'll do everything. We'll manufacture it in China for you. And,
yeah.
That's crazy. So what about this price? So you were saying you were beating up on the
vendors?
Yeah. So you said you were beating up on vendors and getting prices and stuff like that. But I remember in the past you had said that you had trouble kind of getting traction with them. So how do you go from being you don't have a big brand name behind you because you guys are getting started still. How do you actually get the attention of vendors and start being able to push for better pricing?
Yeah, so getting pricing on units and tools and for your bill of materials is extremely difficult because, like you said, you don't have a reputation yet. So you have to play a lot of games.
lie.
Yes, you have to try
stuff.
to lie, but these salespeople are pretty savvy and they catch on to you pretty quick. So,
You send them your Kickstarter link, and you're like, "Come on, look at that goal! Come on!"
No, but we were working on the bill of materials way before the Kickstarter was even going, because we wanted to know way before exactly what it was going to cost to buy all the tools. And
well, you have to. It's essential.
Yeah. So my background in toy design, I kind of know what a tool will cost, and I just confirmed that I haven't done a toy in a few years. I wanted to make sure it hadn't doubled in price, and so I contacted a few contract manufacturers and confirmed that, a single pull soft tool for plastics is, it's $4,000 or so, depending on what you do with it. Mm-hmm. And then, but the actual cost of the micro displays and the metallized gate array and all the stuff in it that we were going to do, that took a lot of work, because just like Dave said, I had to try to lie at first, and then when they got savvy with that, then I had to come back and say, like, well, here's our projections, which is just another way to lie. And then
I know that one too, yeah. You do that at established companies too. It's like, I don't know what the hell this is going to do.
I know. I've worked with like toy companies where we are going to buy like millions of units, and you go through the same dance anyway.
Right.
And then the last thing you can try is just appeal with them, like, hey, we're a small startup, and sometimes that works. And it took a lot of work.
I'll give you 2% of the company, the Kickstarter.
So around September, we started feeling really confident about the bill of materials, and we had second sources for a lot of the stuff in there in backup plans. So Rick and I were lots of backup plans. Like, what if our micro display manufacturer disappears before we actually do our purchase of the units? And what if, this little tiny metallized gate array company disappears or decides to double the price on us? And so, we felt very confident about all of our backup plans. You never want to do anything where you're only single source.
Of course. Yeah. That's interesting. I guess it helps too, because a lot of this stuff, I mean, I think about like the metallized gate array. I think about a lot of chips these days where, I'm designing chips in that have very specialized footprints. The chip vendors want it that way, so it's almost by design single sourced. But then when you guys are doing that with the metallized gate array, if you have to do a second spin, you're going to be doing, it's all custom anyway. Well, relatively custom anyways, right? I mean, you can
could actually choose your bonding pads and stuff, and maybe get it close. You don't have to reroute everything, or you might have to reroute a little bit, but you can make it easier on yourself. And it's great. You can and a lot of times just put things on the side of the chip that you want. So if you have a right and left micro display, you just put those pads right and left on your die. And
oh, nice.
So it makes the design smaller and more reliable. And so that's all the stuff we were looking at. It's like, what are for the metallized gate array, what are the underlayers that are available to us? And can we get all the IOs we want? Can we drive that many IOs with simultaneous switching? So that's one of the things that we wanted to make sure before we committed to some, super low cost gate array, that we wouldn't run into trouble because we're pushing 24 bits of pixels out simultaneously to 2 micro displays.
Is that a serial connection, or is that parallel out? I got lost.
The ones we're using are parallel, although a lot of displays and cameras are going to this MIPI interface, which drives me nuts.
Do you know what that stands for, or no?
Oh, it's for mobile displays, and it's kind of a universal interface for everything mobile. Doesn't do anything well.
Tell us how you really feel, Jerry.
All right, I take that back. I'm being a little bit harsh because people will flame me for saying that. It does do some things good, but for what we're doing, it's not so great. The big advantage to MIPI is that the link can be shut down at any point. And for displays, there's different modes. If your display supports it, you can only update parts of the display, not the entire display continuously. So you can cut the serializers and cut the power. My gut feel is that designers are going to be lazy and just use it in the streaming mode anyway, and it's going to burn power anyway.
Right. So what is power a concern for you guys? I mean, I know that the gate array will help with power, but could you tell us about your power stuff on there?
Yeah, it actually is a big concern for us. We have a mobile strategy. We're going Android, so we want these to run off of cell phones. Currently, we're doing a lot of processing on an FPGA, and it's burning tons of power. So our current glasses, you put them on and they feel kind of warm, and that's all from the FPGA that we have up there right now because we're just pushing all this wire load and all the routing matrix.
How much power are we talking here in watts, just in the FPGA?
I haven't measured it because it's not a big concern. We're moving away from it. Although there's an interesting situation coming up where an FPGA vendor wants to win the design. So,
yeah.
And they have some interesting parts that might be low enough power.
Don't trust them. FPGA vendors keep saying, "Oh, we're going low power. We're going low power." It's like, yeah, okay, sure. All you got to do is turn all your gates off.
Well, exactly. Well, that's one of the things that we haven't optimized for, and that's going to happen in the next year. Is like right now the design is just running continuous, like the pixel pipeline. Like I don't need to be toggling all these bits, but it's toggling just this huge pipeline anyway in the blanking and the vertical and horizontal blanking, and there's a lot of room to cut power. But the biggest win would be going to the metallized gate array.
Yeah.
Talking about the FPGA vendor that wants to win the design, they came back to us like, "Oh yeah, we can hit the price point that you want, but it's going to be a one-time buy."
Oh, jeez.
And I'm like, no way are we going to agree with a one-time buy and have you double the price on us when we actually want to make another batch of these things.
Well, what we'll do is we'll sit at a table and we'll put one bullet in a gun. And wow.
How easy is it to transition from the FPGA to the ASIC? Can you go into the technical details? Is the gate array going to be exactly the same circuitry as what you're currently running in the FPGA? But it's just
not always
translated,
not always.
Right?
So it all depends on your design. And so from day one, I anticipated that we were going to do something like this. So there was things that I did to the designs to really simplify the conversion to metallized gate array or even a full custom. The first thing you do is you never use any of the FPGA IP if you can help it.
Oh, that Xilinx crap, that the 9K memory block stuff. Is that what you're talking about?
Yeah, you got to use that stuff because it just
I know
it's there. But what you do is you put wrappers around everything. You put a generic memory interface, so you don't directly infer anything into your design. So you can infer a memory by just making an array and coding it that way in your Verilog. But that's very hazardous because you could break your design when you go to your metallized gate array or your custom ASIC. So it's
or
better
even a different FPGA vendor, right?
Yeah. You're moving to another design or another vendor of FPGA. So you do that. Like the memory wrappers, I always make those with really straightforward names. So it's like chip enable bar, right? No, in particular the polarities of them, which that actually bit me once in a design where I got the polarities wrong and almost bricked an entire chip because the ASIC vendor supplied an I/O that had a different polarity enabled than the other, but luckily software to the rescue, they were able to save the chip. But
not.
Yeah, in software we're able to fix it. But if that was a memory or something like that, the whole design would have been a complete waste. Hopefully that comes out in simulation, but
right. So would you be avoiding internal PLLs and SerDes units and stuff like that as well?
Well, sometimes you can avoid, again, put them in wrappers.
Right.
Like we need PLLs on our design and we need memories. And we're going to have to use potentially SerDes if the vendor has a fast enough one.
Oh, so the gate array guys, they all have that. I guess I don't understand how the IP stuff works as well. Like, I mean, I always hear about the SerDes stuff on FPGAs, but is it like that's just a block that every kind of chip vendor can drop in these days?
Sure, yeah. So memories are just a block, and SerDes are just that's an analog plus some digital on the IOs, and so they plop a certain number of those around the perimeter of the chip, and they're there. And PLLs are also the same. Those are all hard macros that are.
And we should say too, SerDes, because this confused the shit out of me for years. SerDes is serializer, deserializer, and so you basically can go from a parallel to a serial stream for like one wire, or a couple small wires back up to parallel again whenever it gets there. Because sorry, that term always got me. So I'm sure some of our listeners are slamming on their iPods.
What is it?
You tell me the answer.
And the reason I'm concerned about SerDes is that those are a problematic area going to a full custom design. They don't always perform as well as something that gets hammered a lot more like an FPGA. And so we built in backup plans into this too. So for our design, we're receiving HDMI video, and that's what we want the SerDes for, is to receive that video. And if that doesn't work, we've priced in worst case what it would cost to get an HDMI receiver and put onto the glasses. So
right,
and that's like a separate chip.
A separate chip, yeah. So we would just eat that cost.
Why
but
didn't
ideally,
you do that from day one? Like, just eliminate that risk. Is it the power cost targets you were trying to meet? Because if it was me, I'd go, I don't want to deal with that shit. I just want to, I want the lowest risk. I don't want to deal with a HDMI interface. Screw that. I'll just buy a chip off the shelf that does it.
That's true. But there's also power. You're deserializing the HDMI and you're converting this to 24-bit digital, and then you're transmitting that again. So all those IOs are toggling, which that's a big penalty.
That's a lot of data.
But because it's a dedicated chip, isn't the power going to be similar to what you'd get on your own custom gate array anyway?
Yeah, but you go off chip and then come back on chip. There's a pretty big power penalty for that.
Yep.
Yeah. Pushing electrons across traces.
Yeah, you're pushing all that
capacitance. And exactly.
Yeah. So ideally, best case, we're going to get that onto the ASIC, and we're going to cut, a little bit of power out of the design, and moreover, we want to make sure that we cut anything that'll generate heat, because that's one of our bigger concerns right now, is that these things don't get warm. Right now, that the FPGA on there, they do run warm because that FPGA is grinding pretty hard on all this data. So we're doing a lot of cool stuff in the FPGA. We're doing all the tracking for the head tracking. So we're recovering IDs of these modulated LEDs that you can put out in the world. We're calculating your position in the world. We're also stabilizing the video that's coming up from HDMI. So we're doing some magic work to the video to make it look more like the video is actually locked to the world. So
that's cool. It's like frame shifting and stuff like that, or how does that? So first off, how much are you allowed to say about the technical details? Because I think last time you were on here, you said once we're funded, we could tell you everything. But then I'm sure that there was patents and lawyers and everything else. So
we
have the source code?
Yeah, we are patenting some of the stuff, and
we can just go read it then.
Yeah, exactly. But it'll be way out already in the market by then.
Yeah.
That's part of the VC thing, though. The first thing they ask you is how many patents you have. So
yeah,
we have to look
grown.
Yeah, I know. I wouldn't do them if I didn't have to. But we have to make the company look, attractive.
Dollar bills, y'all.
Hopefully didn't Apple just win a patent case for rounded corners on a phone?
Oh, did they?
Don't get me started. Yeah.
So I should patent rounded corners on glasses.
On FPGAs.
Yeah. Now, last time we had you on as well, I think we were talking about the gate array being a sort of like a product technology in its own right. Are you still targeting plans to sell that technology so that people can buy that ASIC and integrate it into other stuff?
Yeah, there has been some interest that way, and we actually made our Kickstarter a little bit more confusing, anticipating that people would want to buy this tracking system and do stuff with it. And in the end, the people that I think we only sold a dozen tracking packages.
Right. Yeah, I see it. Yeah, you sold 11.
11, yeah. What a mistake we made. We should have just forget it. It'll be available on our website after if you want it.
Yeah.
Because you have to deliver to those 11 backers, right?
Yeah, so it's a custom SKU. I mean, we'll do that by hand, but
yeah. So then, what would that be then? So then the idea would be if you had the chip by its.
I'm sorry, you guys walked on each other.
Oh,
we do that.
Dave asked if you can just give him an upgrade.
Yeah, it might be worthwhile to just hey, sorry guys, here's a pair of glasses.
Yeah, we'll give you a full package. Yeah, exactly.
Yeah. So if you did produce the chip just as it would basically be just outputting coordinates or what? I guess what is output from the chip then, and then so the actual ASIC itself, is that doing everything, or is then there's like a ARM chip on there or something like that is doing the microcode stuff?
Yeah, so it is giving, as it sits now, it's outputting a bunch of stuff, but it's giving coordinates to all of these LEDs in the world. And then we have a little bit of code that's sitting on the PC that is calculating out your world position. And so we're actually talking about bringing that up into the glasses just to cut back even more of the bandwidth. And the reason we want to do that is cell phones are really complicated to interface to because they're so fragmented.
Yes,
it's a nightmare. It's
and you don't want to standardize on one phone and then 6 months later it's gone, right?
Not all the phones have USB. Some of them have USB, but when you plug a video connection into them, you can't access the USB. So our solution is for mobile, we're going to have an option where you can modulate the coordinates over the microphone input.
Wait, what?
So just like a modem. So we've done some tests and it
old school, dude.
Yeah.
Well, yeah, I know what a modem is. But wait, the phone's audio inputs would plug into the headphone jack or what?
Yeah. Because that's the only lowest common denominator on a phone is the microphone input.
And you actually get very reasonable, deterministic, and that's important too.
Yeah, right.
Interface with high bit precision. So there's a potential there we don't need to push a lot of data across, but if we ever decide we need to, we could actually push a whole lot of data across the microphone. So we've done some simple tests and proved out that it works. And so that's going to be our strategy on phones because phone manufacturers can't get their act together and come up with a nice set of interfaces.
Yeah. Well, a lot of people go to Bluetooth as well, I guess, but then that's not deterministic, right?
Yeah. When you're doing head tracking, you really want a deterministic link because when you're swinging your head left and right and the computing device has to figure out where your head is in the world and generate the right video. If you drop a packet, that's pretty darn bad as far as visually what it looks like. We tried Bluetooth and we're like, this isn't gonna cut it.
Especially not for the power. It's probably not worth it. I mean, if you can just run a cord.
And cost. We had to be corded anyway because of the video out.
Yeah.
It's still going to be a bit of a nightmare relaying the message to folks all right, you have an MHL connect, need to get this HDMI out to... Hopefully, in a few years, things will be a lot simpler. So we're going Android first, and then Linux, Mac OS, and then trying to work with iOS devices, which they just mixed everything up on their recent phones too, as far as connectors.
Huh. So, yeah, I guess that audio would be the most universal, huh?
Yeah. How
much bandwidth can you... I mean, I guess I think about it as the microphone side of things. So microphones themselves are usually, sub 10K, right? They don't need to actually catch the higher frequency stuff, right?
But you just look at... let's say we were going to go even 56K, that went across phone lines that I don't remember what the bandwidth was on phones. We don't even need that much bandwidth, but...
2.5, 3 kilohertz.
Yeah, so that was extremely limited.
But that's actually complicated technology, the encoding which gets you 56K baud down a phone line. That's not trivial stuff.
We wouldn't want to do that on a phone. Yeah, but you're looking at the analog to digital converter, 16 bits at, in the kilohertz range. It's a lot of bandwidth sitting there.
I guess I was a little confused about. I was thinking that this had that. So is it mostly just going to be the ASIC then, or the metallized gate array? I always thought there was another processor on there for some reason.
Oh, there's a 6502 sitting on there right now. We may not stick with that in the long run. I had the 6502 IP from a bunch of toy designs I did, so I stuck it on there, and all it does is it wakes up once per image sensor scan, does a little bit of housekeeping, then goes back to sleep. But if we actually put the world solver on there, we're going to have to beef it up a little bit more. 8-bit arithmetic's just not going to cut it.
Right. So that's still on the ASIC though, right? I mean, that's not that's not off chip. It's all still single. So it's just going to be single chip solution then.
Yeah, that's our main goal, single chip solution. That way we can keep costs down. And then that sets us up for the part of our math that's being done on the PC side. It doesn't necessarily have to be floating point, but it is in floating point now, so it has to be converted to fixed point. And we'd probably look at one of the open source 32-bit processors. Again, we can't use like a Neos or what do they call it on Xilinx? They're
Microblaze.
Yeah.
Ugh.
Actually, I worked on a chip once where we emulated on an FPGA, and then the management team decided like we were using the Neos processor, so they're like, "Well, we're just going to stick with that." And, oh my gosh, that was luckily I didn't have to do the work on that, but it took like 3 or 4 people, 4 or 5 months to make it ASIC ready. After we licensed it, it was really bad news.
What about the OpenSpark? You could do that one, where they open source the Spark core.
It depends on how big they are. I mean, I think
they're huge.
If we actually go the route of putting the world solver in there, we're going to have to actually look at the algorithms very closely and first prototype them in fixed point and see what needs to be done. And maybe the 6502 could do it with just a little state machine there to grind through the math.
Right. So how much is an ASIC going to cost you now for NRE?
It depends. It depends on how many metal layers that you do. So we anticipate at least 3 metal layers. And it depends on the underlayers, which is the base substrate. Mm-hmm. So it's about 15K a metal layer. And that adds on top. And then they charge you more if the underlayer is bigger.
And who are they? Who are you dealing with to do the FPGA? Because I think we talked about this on the previous show.
GigOptics used to be ChipX.
Right.
And then we've been talking to eASIC, which is, they have kind of interesting devices. But hey, eASIC guys, work with me, please.
Are you out there? Can anyone hear me?
And there's Atmel too. There's Atmel that does some units. But really the GigOptics guys, the old ChipX guys have the most interesting parts right now, and eASIC have the most interesting parts.
So what tools are you using to do the ASIC? Are they all different?
Oh, so I just use I just use the tools, on site with them. So when it comes time to synthesize it, I just walk in the door with a big pile of Verilog and then
got it. And
sit down with them
there for a month and
it doesn't
take
that long.
How long would it take?
It doesn't take that long. So you get it working on your FPGA. I use all the free Altera FPGA tools currently, and then I do it with the same design methodology I was talking about with all the wrappers and stuff. So when I walk in the door at Atmel or one of these places, they're going to give me data sheets to their memories and their IOs, and then I just have to wire those up. And then we do, I need to walk in the door with my test benches, which that's something.
I was going to say, it's all about testing. Yeah.
Yeah. So that's one thing that needs to be done in the next year is test benches. Because since I'm doing all the emulation on FPGA, I've been using the shotgun method of, stick it on the FPGA. It works. All right.
Yeah.
So there's actually, so if I back up before I walk in the door, there's probably going to be a good month of someone sitting there coming up with all the test vectors. And then we walk in the door, we hook up the IP, the IOs and the PLLs and all that stuff. And then you're going to spend 1 or 2 days just trying to get the thing out of reset. That's always seems to be in simulation. I don't know why. It always seems like that's the biggest issue, is trying to get all the signals on the pins asserted correctly to get the thing to not
yeah, but the reset works, though, right? I mean, that's important.
Well, you always bypass. Like, here's the issue with reset, that it'll have a global reset on the chip, but you want to bypass for the first simulations your power on reset circuitry, because you don't want to wait for
all that
a tenth of a second of simulation time for the power on reset to click on. So that usually causes some headaches, because it's when you assert the global reset relative to all your clocks in your design, you can get the red X of death that's propagating through the design. So that's for the listeners that don't know, in a simulation, whenever you get an X, an unknown condition, which can be just like a small timing issue, it will propagate through your design. So your design might be running, like one corner of the design will be looking like it's running great, and then somewhere out in time there's this red X of death that's propagating from somewhere, and it'll hit that block, and then it'll go red, and it can be very
else does.
yeah, and everything from that time on is unknown, so it's X.
Yep. Oh, that's a mess.
So that's just going to be a behavioral simulation at that point. And then once you get confident of your test benches, they're going to do a synthesis run on it. And then you're going to do gate level sims. And then those take a lot longer, because you're actually doing wire load and gate propagation delay.
So it's like a huge SPICE simulation at that point, right?
Yeah. So you make sure that helps you. The synthesis tools give you an idea that you've hit timing, but then you run simulation to see if it's actually true. And then you might take a step back and put your power on reset circuit in there and make sure that all that's good, and various other things that might take a long time. Once you've proved out your timing simulations, and then you do these really long, 2-3 day simulations.
I'm thinking that you should have just
a lot of coffee.
done another Arduino compatible Kickstarter.
I know.
That's a good point.
Well, then we got to go through FCC certification.
Yeah, I mean, this is a big deal. What if? Which countries? How big a deal is that?
Oh, it's going to be huge. Actually,
yeah.
I'm actually kind of concerned about some of it.
Yeah.
The glasses, I'm not so concerned about. But we have an RFID grid.
Well, did you guys have a reward level for that spark gap generator? You were that hidden level, that $20,000.
Well, luckily, the glasses are pretty manageable as far as the unintentional radiator aspect of them. But the RFID grid, it's an intentional radiator. So FCC Part 15 intentional radiator, was that C or something? We have an entire array of RFID pickup coils, and they're all resonant circuits, and they're
and you got a whole mat full of them.
A mat of them, right?
At 13 megahertz.
13.5, and it could be fun.
It sounded like a good idea at the time.
And that was one of those things that we have a lot of faith in this design. It's the right way to go as far as the interactions, but it didn't sell nearly as well as we hoped. So this is going to be one of those things that we're going to do in faith.
Amount of effort versus number of backers you got.
Yeah. So I don't know how many we sold. There was a kit in there that had the
8. You sold 8 RFID tracking grids.
No, there's more than that. Those are people that just wanted to play with them by themselves.
Just wanted that, right? Okay.
There's a kit that includes it, so we probably only sold a few hundred RFID grids, and so we believe that's going to be the best way to play these kind of board games, but. We're going to develop this, and we're going to continue to sell it, and we'll go through all this pain, and we're going to lose a ton of money on it. But
did you?
That's the fun part. Come on, Jerry.
Do you get the feeling that you bit off more than you could chew in terms of number of things that you have to deliver?
It's a lot of things. It is. This is if I compare it to, I was constantly comparing it to toy designs that I did that would be 1 or 2 items. And we're talking about, we have the RFID grid, which is going to be painful. We have the glasses, which is electronically is pretty well done now, but mechanically it's going to be painful. Wand, little RFID pucks, which aren't going to be any effort at all. Yeah, so there's a lot. I bit off a lot.
When you say something's not going to be a lot of effort, right? You just cursed yourself like crazy.
Yeah, right.
Yeah, it might be the biggest.
Oh yeah, come on. You just tempted Murphy pretty bigly, pretty huge. Yeah.
Okay, the RFID pucks is like overmolding an RFID tag into a piece of plastic. So
that's right. That you just buy off the shelf.
I have pretty high confidence. Yeah.
I'm just saying.
I know.
I'll be shipping next week. All right.
Yeah.
Yeah. So okay, go ahead.
What about the X factor here of where's all this stuff? Like, are you going to be in China this whole time? Where are you guys looking at manufacturing?
It's going to be in China. I've already been talking to contract manufacturers in Shenzhen, so some companies I worked with, and some interesting things. Talking to these companies I worked with before, is we were doing hundreds of thousands of units, and I'm walking in with talking about thousands of units across, 5 different items. They're a little bit less.
They're just not going to care, right?
Yeah, they're not quite as excited.
Most of them, yeah.
Yeah. So that's been a bit of a challenge. We're rapidly working towards buying our capacity in one of these factories, and we want to try to lock that down because we're going to be competing with a Christmas production run with other companies. Yeah.
So 2014 Christmas, is that the idea?
Yeah.
That's the timeline.
So we're going to start shipping in September.
Of which year?
But yeah, we have to compete with the Mattels and MGAs and the big companies that are wanting to get capacity in these factories. Gulp. So we have, it's interesting. There's been some domestic contract manufacturers that contacted us during Kickstarter and post Kickstarter that are saying that they can do the same price. I'm still very skeptical. So one contract,
I'd be serious looking into that because, going to China sucks.
It does. Although the quotes I'm getting back from, there's a particular company in the Bay Area that came back with a per hour test assembly and per hour assembly and test of $15 per hour, which if you even just start crunching those numbers, it's like, how can they even do that? I mean,
sneak the units to Mexico.
You're right.
They can. It was bullshit numbers they're coming back with.
Yeah.
They gave a range of it's somewhere between
$40
and $15 an hour test and assembly. So there's absolutely no way they're going to hit $15 per hour. You just look at labor alone. It's like, I'm sure minimum wage is about $12 in Silicon.
I don't know. This is America we're talking about.
Unless it's all illegal immigrants or something. And yeah.
But that might be the thing, though, right? Because your volumes are relatively small. I mean, a couple of thousand is small volume for China. I mean, almost to the point where they don't even want to talk to you.
But it's the tools. That's the problem.
Yeah.
Right.
Especially the design and everything, right?
Yeah. So cutting tools in the United States is really expensive. And if you cut the tools in Asia and transport them to a place that'll do the plastic press in the United States, there's all that logistics time.
Yeah.
Well, you could do the plastics in China, but you could do the electronics in the US, perhaps, because there's a lot of issues in the electronics manufacturing side of things where you need,
someone on the ground,
feet on the ground. Yeah.
Our plan from day one is that, unfortunately, it's probably going to be me and whoever's doing the tooling is going to be over there babysitting the entire time. I've been over there for toy production runs, and the way it worked for toys is I was never over there during the setup of the production line, but I was in close contact with them. And then I would land on the ground the day before we did the actual pilot run, and we would run off 100 units with a skeleton crew. And we would check for yields and kind of see what's going on. And if there was any like yield problems, we'd open the units up and I would try to identify like, oh, you're shorting these wires out because you've, this step of the production line. We might do another pilot run or two, and I might be over there for a week. And of course, this is for big production runs where that's when they bring the whole lineup, is when I was leaving before. And then the toy companies had folks on the ground that, oversee the whole thing for the next 3 weeks.
Yeah.
But
QA
now
type
it's
people.
you.
Yeah. There are a lot of contract manufacturers that look very eager to work with us. So it looks promising. I just, it's hard knowing like even the bigger, more reputable ones, the corners that they cut, that, they're not just blowing smoke up our ass, and then we get over there and they don't have the capabilities to do the assembly that we need. Because we're going to have optics assembled, so we don't want fuzzballs getting into the optics path and stuff
Someone's
like that.
Hair falling in.
Exactly.
There goes the cat assembled units, just like you wanted, Jerry. Dogs rule, cats rule. So you've been over to Shenzhen before, though? Like you've spent time over there and stuff? Okay.
Yeah, quite a bit. Almost every production run I did on toys, I'd go over there.
What's the last time you were over there? I just wonder because it seems like that area still is changing so much as well.
It is. I think it's 2008 was the last time I was over there, so it's been quite a while.
Yeah, okay. That's cool. Well, it seems like there's a big contingency of people of expats over there as well, like that
are in the same horrible position of having to babysit their thing for production.
It was kind of interesting. Together. I was talking to a lady. I was hoping to recruit her to help us, that she had been working for a big company that makes cell phones. And I talked to her about 3 years ago, and she was, I love being over in China and doing these huge production runs. And I was going to see if she could help me out this time. And I contacted her, and she's like, I'm not in China, but screw that shit. I'm not going over there again. And she got so tired of it.
Bad experience.
Yeah.
Are you going to have to hire a Chinese-speaking technical person? Because that could be vital.
Yeah. Every time I've been over there before, they gave me a person that just, the factory actually supplied the person.
Yeah.
And so the kind of funny thing when I was over there before is they'd be chattering about something technical, their engineers, and there's enough words that are the same. I could follow what they were talking about, and I would surprise them sometimes. And they'd be like, blah, 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 transistor, blah, 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 resistor, blah, blah, 1K, blah, blah, blah. And I'd be like, no, don't put a 1K in there. And then they would turn to me and like, oh, do you speak Cantonese? I'm like, no.
I speak resistor values.
Yes.
Red, orange, brown, green.
So what's your greatest fear in terms of manufacturing? Is it the electronics? Is it the optics? Is it the ASIC? Is it the plastics?
I think it's the plastics by far. I fear that we're going to burn a lot of time in the first part of the year trying to compromise on the industrial design and something that's manufacturable. So I'm going to try to avoid one of the pitfalls that I've seen at a couple other places where, and this is what was going on at Valve when I left there, it was the industrial designers were ruling the design. And I could see that they were coming up with stuff that wasn't going to be mass producible.
Super fancy curves and everything.
Yeah, you want it to look nice, but you got to get the industrial designer out of the picture early and get into...
You need the structural engineer to tell the architect to shut the hell up at some point.
And we're even debating...
Artsy-fartsy.
Yeah, we're even debating not doing industrial designer at all. We're hoping that we'll find some mechanical engineer that's the unicorn, right? That has a good eye and kind of knows what feels good. Like for the wand, we kind of want it to feel good and not cramp your hand up, but I don't think we can burn 2 months of industrial design experiments on that. We just have to, get it 90% of the way right away, and then start working on the stuff that's going to be important, like the mechanics for the triggers and the
exactly. And I was going to say, is it that important? I mean, you've got to deliver. I mean, it's all about delivery.
Dave's about to tell you to put it into a Hammond box or something like that. Yeah. Just slap it in there and send it out the door. See, now I wonder about this because it seems like even with mechanical versus like design kind of stuff, it seems like even still with mechanical engineers, the electronics always ends up a slave to the whatever shape they give you, right?
Yeah.
But since I think your title is officially president, right? Are you allowed to be like, no, this is a rectangular board, and my foot is down?
Maybe. Yeah. We're definitely going to run. Working at Valve was very interesting. The structure of it. And we're gonna take some of the self-guided feel of Valve, and we're gonna try to structure our company that way. But there's definitely going to be a management layer. Like Rick is going to mandate certain things be done in software, and I'm going to mandate certain things be done on the hardware side. And just we have to. We don't have enough time.
Dictatorships work.
Yeah, Jerry and Rick, benevolent overlords.
Yeah, totally open to people's suggestions, but. Our goal,
don't like them, shut up.
Yeah.
So our goal is the first 5 months we're going to lock the hardware. So
that's good.
Yeah, so there's going to be no more
feature creep.
Exactly. And it's going to have to be that because we're going to be spending 4 months of time designing the tools, cutting the tools, and all that stuff. So we can't be adding any more features 5 or 6 months into the design. It might be unfortunate, there's probably going to be a few things that we wish we can change, and it's like any project though. I think mechanically the two things that are going to be challenging for us is the wand, because it's got an analog joystick. That's kind of an off-the-shelf part, but all your clearances have to be good there, and the buttons. And then the trigger, all that, we're going to want that probably to be mounted off of a single PCB, so it's all on one plane. So that kind of limits where all these things can be.
Yeah.
And then the glasses, I think one of our challenges is the electromechanical on the wiring going from the bending arms and the connector to disconnect the cable.
Right.
We want all that to last and be good.
And then a cable actually running down to the unit or to the phone or computer, right? That's the other thing. Huh.
And there's a little box on the end of that, so that's engineering too.
And then there's 3,000 people emailing you for the next 12 months saying, "Where are you at? Where are you at?"
Hopefully we can keep the communication up so they can see it happening along the way.
Yeah. Actually, tell us about that.
So the Kickstarter was... Oh my goodness. As far as...
Yeah, it was... We haven't talked about this. It was full-time work,
It
was. For a month.
We thought we would be different. Everyone told us it was going to be full-time work, just doing Kickstarter and communicating with people. And we were wrong. We spent most of our time answering emails and doing press things. And
you were doing 3 a day at one point.
3 press things a day or 3 somethings a day. We kind of divided our day up into morning, mid-afternoon, and then kind of mid-evening, and we tried to schedule that way. So the first week was 3 things a day. So we were driving around going on like Revision 3, and then we went up to This Week in Tech and Hack 5 and talked to New York Times and talked to various folks. And then it slowed down to about 2 a week the following week, and then for the rest of the Kickstarter campaign, it was about 1 thing a day. But the emails never slowed down. Never. I mean, the first day was ridiculous. We couldn't keep up at all because we had, I don't know how many people asking details and bitching about shipping and all this stuff.
Yeah.
But it seems... It is about time we do an update, I guess. It's been a week and a half or 2 weeks now since the campaign, but...
Oh, no, people will start be screaming scam already.
Yeah. But hopefully we can do something a little bit more regular like that. Like, as soon as we get a little piece of plastic designed, we can show show them.
Yeah.
But what's kind of interesting is we learned a lot from people's opinions during Kickstarter. It would have been really nice if we could have got all those opinions before we did Kickstarter. We could have been so much more successful.
Yep.
Can you start your first update video with you and Rick walking out the door with big bags of cash? You guys are bailing,
hopping on your plane to the Bahamas.
Oh, hey guys.
Never mind these bags of money.
Yes, exactly. Oh, right. Cast AR, that's definitely a real thing. We're gonna go make it real now.
Wow, it's. Well, we were watching all these kind of scammy Kickstarters all summer, and going oh man, you guys are ruining it for us. There was, and really big name ones failing, don't do this to us.
So do you think that really hurt you? You think you would have been got much more 12, 15 months ago?
I think so. I think a year ago, people were more optimistic about it, but there's been a lot of video game things that have failed. So
yes, very spectacularly. We're talking $10 million ones too, aren't we? Multi-million dollar.
Yeah, burning through just tons and tons of money. You think?
And most of those were just software, right? They weren't even hardware.
Well, here's the thing. We look at hardware. That's you actually have to build things, but
it's infinitely harder.
Well, I don't know about that. I mean, you look at a video game, though. It depends on the software. Just wandering around the halls of Valve and looking at how many people it took to do Defense of the Ancients, which was it pretty much was just one game map with just a bunch of characters that ran around this map the map, as far as I could tell, never changed.
But the video games are so stupid these days. They're like Hollywood productions. Give me freaking Duke Nukem Platform Edition or, Frogger.
Well, that's where all the money goes. That's why it's probably worse for video game Kickstarters than it is for hardware.
Because the expectation's high, right? Is that these days?
I would say so, because, here we made all the prototypes. We showed that all this stuff works, and it's pretty straightforward. Now we just have to execute on it, and we know ahead of time what it's going to take. These video game productions, they, because of the psychology thing we talked about before, they probably can't come out and say that this is really a $5 million production, because they would never get it. So they have to set it at $500,000, and then they get painted in a corner when they only make $1.5 million, and then they run out of money, and then people start getting jaded about Kickstarter. Yeah. I don't know what's going to happen with Kickstarter and all this crowd source stuff in the future.
Well, it's not going to go away, but I think the hype period is probably over, or starting to decline anyway.
Sure. There seems to be a lot more software things not getting funded these days. Rick and I watched all this stuff very keenly all summer. How is hardware doing? How is software doing? Should we actually take some VC money and forget about this Kickstarter thing? And in the end, we were we still think it's viable to do Kickstarter for hardware. I would not do a software project. Right. You would never get the money that you need unless it's very specific. I think probably our hacker electronics community could do it. If someone wanted to do a software-defined radio program or something very well-defined, they could probably pull in the money. But big productions like video games, I think, are dead.
So could you have taken VC funding before the Kickstarter and you chose not to?
We did. Yeah, we decided not to. Actually, you asked me what my biggest concern was, and going into Kickstarter was staffing up after Kickstarter was my biggest concern. No, correction. My biggest concern going into Kickstarter is we wouldn't get funded. Second concern is we'd only get $400K. Third was that we wouldn't be able to staff up if we did get funded at $1 million or more. And then fourth, I guess, is plastics and all the mechanics and what goes into that.
Tick them off one at a time. You've already got 2. Keep going.
Yeah.
Huh?
Step 3, go on the AMP hour and see if anyone wants to work for you.
Oh, yeah. Anyone who wants to work with us. I think it's jobs at... Jeri, Jeri, at technicalillusions.com.
Because she doesn't get enough email already.
Yeah. It's already gotten out onto the web, so it's kind of noisy.
It's pretty hard to figure out email addresses these days, too, so...
Well, filter it. Put job in the title, and then you can set up a filter on that.
Mechanical engineers and electrical engineers is what we're looking for, especially if you, on the electrical side, intentional radiators.
Right.
You love FCC testing, and who doesn't, right?
Yeah. If you love staying in a Faraday cage for hours at a time.
Yep. Do you live in an anechoic chamber already? Well, come on down.
Come on down to Technical Illusions.
I might just have to put a jobs listing up for that.
Like a anechoic chamber gnome or troll or something.
Oh, brilliant.
I worked with a guy that was so good at doing FCC stuff, and it was all intuitive. So he would use stuff like he had a ham radio, an old ham radio, and he would dial through and he'd listen to the chirps on the ham radio. I mean, he had his spectrum analyzer. He knew where he was, failing just by the peaks. But then he would tune them in on his ham radio, and then he could have his head down working on the circuit, and he'd be poking his fingers on stuff, and he'd be taking leaded capacitors, but he would be listening to the sounds coming over the ham radio, and if he attenuated something in the spurious, frequencies, he would hear it. And
that's like the character in Sneakers, right? Like the deaf guy or the blind guy in Sneakers.
The blind guy.
Redford movie.
Yeah.
That's awesome.
Which it reminded me of, like in the early days of I was doing electronics, I would use things like headphones to try to debug circuits. So there is a lot that you can learn. Like these piezo earphones are great. You can just hook them right up to slow digital circuits and hear what's going on and when things change. It's actually a lot to be learned by sound.
Or just listen to dubstep, and it sounds pretty similar, right? I mean,
yeah,
a couple more lows in the dubstep, but
maybe I shouldn't have got into this high tech like AR glasses thing. I should have just made a circuit bent something.
Yeah, exactly.
Kickstarter.
Yeah. You would have got the same amount of money with
poke with your finger capacitor.
A lot less work.
100 times less stress. Yep.
But there's I wouldn't be happy just doing the easy thing.
Right.
No,
we know, Jeri.
That's it punishment.
And it makes me feel good that this is something that Valve tossed away and we made something of it.
Yes, stick it to the man. Yes.
I'm sorry, I'm vindictive.
Well, Jeri, when can we have you back on to hear about the updates? I'm guessing to 20, maybe this time next year. You think you'll be ready to talk about how it's going, or maybe
when she's sitting in a hotel room in China?
Well, that would definitely be a fun one when we're over there. We should try to do something when I'm in China and I could just tell you all the horror stories live from. I'm
in a factory right now punching my production engineers.
I'm trying to pee down a toilet that's just a hole in the ground. That was my. Yeah, Dave, you've been there, right?
I've been there. Yep. And that's a fairly accurate description.
Yeah. So the first time I went to China, my guide that took me into the factory gave me like a little packet of tissues, and she's like, "You will need these." And I'm like, "Oh, I'm not sniffling. No, thank you." She's like, "You will need these." And I'm like, "Okay." And I just took them to be polite, and I don't know, I threw them in my laptop bag, and then I walked into the bathroom, and it was like 20 holes in the ground.
Yep.
I will need those.
And no barricades between. And I'm a shy peer too, and it's like I'm like, I will need those. So I had to go back, grab them.
Then you
try to do my
a large
thing.
curtain or something, and
quality content here on the Amp Hour, folks.
It's important. It's important. If you're considering manufacturing in China, you cannot be pea shy.
Right. You got to have eyes wide open. And
hey, it's always exciting when I come on. I drop all kinds of swear words.
What was it last time? I don't even remember now. Oh, I do remember
vagina
now.
or something on one of them.
Something vagina. Yeah. Oh, Jerry. All right, so we'll plan to do a live amp hour connection between. Actually, that works out well because that's pretty closer to Australia's time zone. So between the U.S., China, and Australia, we'll do a live production update, and
we could probably do some fun ones in 2014. Also, Rick and our plan is to be very candid about what's going on. So, like, hardware lockdown time, like 5 months or so out from now, should be very interesting to talk about, like, all the compromises that we're going to have to make, and
definitely
what went right and what went wrong.
Just live stream the arguments in the conference room as it always happens.
Oh my, Rick and I get along very well, but there's been a few stressful moments of like. There was 14-hour days leading up to this thing, and then during Kickstarter it was less than 14 hours the first 3 or 4 days, and I mean we were snippy. Yep. It was. I went to Revision 3, which is a web broadcast thing, and Veronica Belmont was going to do a demo and talk to me, and I almost had pneumonia, or I probably did have pneumonia. I was like, so sick, no. And she was like I was like,
nice to see you again.
And she was like patting me on the back. She's like, oh dear, oh. She's so nice, and she's like giving me cough drops, and she's like, yeah, I mean, and she's like, just do the best you can. We'll try to edit it.
Don't die until you go on Hack 5.
Yeah, and so just before. I pounded back a coffee, and then I just like put on this big smile, and I'm like, "Hi, Veronica, it's great to be on the show." Whatever, and I did my like 10 minutes on her show, and then afterwards, like, and she said something like, "I was amazed that you pulled it off that well."
Yeah. Oh my god.
Well, we look forward to it, Jerry.
Yeah. Thanks for having me on.
The horror stories.
I'm looking forward to the horror stories. That makes for good time.
Yeah,
makes it all
being
worthwhile.
in the thick of it with good friends. That's how you get close.
I look back at some of my like really stressful designs I worked on, and I'm so nostalgic about them. It was total hell going through these different things, and in the middle of it, I'm like, I'd never do that again. Or like the Kickstarter thing, I'll never do that again. But 5 years from now, the product will be out, and everyone will
you forget the shitty parts, right? And you're like, I could do that again.
Yeah.
I'm pretty sure that's how most people have a second child. I think that's how most people procreate more than one child.
Dave?
It was so much fun Dave. The first time,
yeah, exactly.
Dave, second child yet? I haven't been keeping track of personal tweets too much.
No, there is no second child.
He has no comment, folks.
Okay.
No comment yet, folks.
Oh, shit, I just commented. Can we scrub that out? The wife will be unhappy.
Uh-oh. I'll give you a couple years, and it'll happen. You'll forget.
Yep.
Sweet.
Back to Diaperland.
Silence. Chirp, chirp, chirp.
Well, it's always a pleasure to have you on, Jerry. Everyone loves when you're on. Almost a regular. You might even be able to break the Jeff Kaiser limit.
Oh, has he been on more than me?
I think so.
Yeah, he's a dirtbag. 7 or 8. So you've got a little ways to go, but you can catch up.
All right. When there's some major breaking news, I'll let you guys know.
Okay.
Awesome.
That sounds good. Well, thanks, Jerry.
Thanks, guys.
Talk to you soon.
See ya.